ExaQUte is the name of the European Union project that stands for Exascale Quantification of Uncertainties for Technology and Science Simulation. Recent advancements in high-performance computing will soon allow for the use of exascale systems in industrial practice. This will bring the immense computational power of today's machines to real engineering applications. The ExaQUte project aims at exploiting such systems, pushing our current physics simulation capabilities by performing uncertainty quantification and optimization under uncertainties. Well, I know it's kind of confusing, but don't worry, we will explain everything more in detail. Let's start with the high-performance computing. While high-performance computing is a broad term, and in the scope of ExaQUte, it's better to narrow it down a little bit and talk about supercomputers instead. We hear a lot about supercomputers nowadays, don't we? But what is exactly a supercomputer? Let's explain this with a simple example. This is Jane. She is currently doing her PhD on statistics. One afternoon, her supervisor tells her to conduct an experiment that involves tossing a coin 100 times and log the results. Being a very smart person, Jane calls 3 friends of hers and asks for help. They divide the tasks and conduct the experiment simultaneously. Jane obviously saves some time, right? Now, think of Jane and her friends as the processors of a very large computer that is programmed to run tasks on parallel by dividing the task to be done. This way of programming is called parallel programming, and supercomputers are massively large computers that employ parallel programming to reduce the total amount of time to be spent on conducting a computational operation. Now let's talk about the uncertainty quantification. But before getting into that, why do we deal with uncertainty anyways? Imagine a very large-scale civil engineering project to be built, and we need to estimate the wind effects on the high-rise buildings. With the current methods, we can already do this job, right? However, what if we don't know some of the input parameters of the problem a priori? Since we don't have an exact set of data as input parameters, we can never end up with an exact solution. In case of a large-scale project, this would put millions of dollars at stake. ExaQUte solves this problem with uncertainty quantification, which is the science of quantification and reduction of uncertainties in computational and real-world problems. The approach of ExaQUte implies performing a large number of repeated simulations with similar but different input and boundary conditions. And it's not only that. ExaQUte takes advantage of the information obtained by uncertainty quantification by combining that with the concept of optimization. Typically, optimization is used to find the optimal design that yields the best performance for a given analysis with a specific set of inputs and parameters. However, conventional optimization may result in fragile designs that are only adequate for the set of conditions they were conceived for. With the combination of the information given by uncertainty quantification and optimization, ExaQUte is capable of converging to a final, robust design which takes into account a wide range of different and uncertain conditions. And its whole concept is called Optimization Under Uncertainties. In ExaQUte, we are a large team with members from various backgrounds, and our goal is to develop all these methods that will be applicable to many fields of science and technology. Combining our expertise and cooperation, and with the help of our resources, we will achieve this.